All right, Benny, this video is going to walk you through some of those problems you had issues with on your 2017 January Regents. Here's number 4. For number 4, it says if sine squared of 32 degrees plus cosine squared of m degrees equals 1, then m equals. What you have to know is your Pythagorean identities. Sine squared of an angle plus cosine squared of an angle is equal to 1. So this said sine squared of u plus cosine squared of u equals 1. So if that first angle is 32, that next angle also has to be 32. Let's take a look at number 6. It says, which statement about statistical analysis is false? Experiments can suggest patterns and relationships. Absolutely. Like if you do an experiment, you can suggest like this. I don't know if they do the experiment of hours studied and how well you do on the test. If you do an experiment on that, you can see like the more you study, the better you're going to do on test. Experiments can determine cause and effect relationships. Yes, they can. Of course, I can't think of a good example right now, but it could be, you know, a relationship between the amount of inches it snows and the road conditions. I have no idea. I'm making crap up. But experiments definitely show a cause and effect relationship because you have your control group, your experimental group. The third one, observational studies can determine a cause and effect relationship. No, they can't. Observational studies can suggest, like there might be a correlation between two things. It might seem like the more you study, the better test scores were for those students. But really, if you don't have an actual experiment in a control group, you can't have a cause and effect relationship. Number 4, what observational studies are good for is to suggest patterns in relationships. You get possible correlations, but not causal. So 3 is the one that's false. There's not really a whole lot of math to that one. Let's try the next one. This one, you need to know about your laws of exponents. So if we want to work this problem out, if I want to take a look here, I could work within parentheses first if I want. I'm dividing. When I divide with the same base, I subtract my exponents. So inside the parentheses, I'm dividing. I keep my base and I subtract my exponents. So that's 2 minus 1/3, still all raised to the negative 1/2 power. So I have to know what 2 minus 1/3 is. Well, hopefully you're comfortable that that would be 1 2/3. 2 minus 1/3. You could multiply, that's like 2 over 1. You can multiply numerator and denominator by 3. 2 times 3, that's 6/3 minus 1/3. Gets you to 5/3. 5/3, 3 goes into 5 once with 2/3 left over. So it's 1 2/3, but we can write it as m to the, so 2 minus 1/3 is 5/3 within the parentheses. Still all raised to the negative 1/2 power. When we raise to a power, we keep the base and we multiply our exponents. So then we have to do 5/3 times negative 1/2, multiply straight across the top, straight across the bottom. 5 times negative 1, that's negative 5. 3 times 2 is 6. So when you raise to a power, you multiply those exponents. So this is negative 5/6 power. We know negative exponents. How do we make them positive? Well, we put it under 1. So m to the negative 5/6 is the same as 1 over m to the 5/6 power. So that's all from back what you learned in 7th grade Accelerated. You would have done this topic. But now let's talk about the high school version of this. First of all, number 1 and number 3, I sure hope you eliminate it right off the bat. Negative exponents don't mean you're going to have a negative coefficient. Negative exponents mean you're going to end up with a fraction. And this is the piece hopefully you know. Hopefully you know if there's a 6 on the bottom here, that's the same as 1 over the 6th root of m raised to the 5th power. Hopefully that's going to be the high school piece of it. So hopefully you've learned that. The number down here in the denominator is what you put outside in the root, and the numerator will be the power you're raising to. So that's the final answer there. And that looks like it's number 2. Hopefully that helps with 7. Moving on. Ooh, this one had a lot of words, but it's not a bad problem. It's actually really mostly an 8th grade problem until you talk about doing 10 times the log of, and you'll use a calculator for that. Okay, the loudness of sound is measured in units called decibels. So D in the equation would be your decibels. These units are measured by first assigning intensity, I, O, that's initial, to a very soft sound that's called the threshold sound. So I, O is your threshold sound. All right. The sound to be measured is assigned an intensity I. So I is the sound to be measured. All right. The decibel rating D, they give you decibel ratings down here. The decibel rating D is found using this formula. So D is equal to 10 times the log of I over your initial or your threshold. The threshold sound audible to the average person is this. So if that's your threshold sound, that must be, threshold sound is your initial I, so that's I with a little sub-zero, it just means our initial. All right. Then it says consider the following classifications. If it comes out that the D, the decibel levels, are between 45 and 69, that would be moderate. 70 to 89 decibel levels would be loud. 90 to 109 decibel levels would be very loud. My voice, it probably falls within that. And deafening would be greater than 110. All right. How would the sound with intensity, so now they're giving us intensity of 6.3 times 10 to the negative 3, what's W? I don't know. I want to say watts. Oh yeah, watts per square meter be classified. So now they're giving us our intensity. Sound to be measured is our intensity. So your I value is your 6.3 times 10 to the negative 3. So we have D equals 10 times log of, in place of I, we do 6.3 times 10 to the negative 3 over the threshold sound is 1.0 times 10 to the negative 12th. Most of this problem involves your 7th grade. You probably did this and accelerate it, dealt with scientific notation. So we have 10 log of, let's see, we have to handle this division. So when you're dividing with scientific notation, you just divide 6.3 by 1. Well, that's 6.3. Times, when we're dividing and we have the same base, we go ahead and subtract those exponents. Negative 3 minus a negative 12 minus a negative becomes plus. Negative 3 plus 12 gets you to a positive 9. So it's times 10 to the 9th. So literally on your calculator, I need you to do 10 log. Make sure you put your 6.3 times 10 to the 9th in parentheses. And once you hit enter, you're going to find it's 97 point something, I think is the answer that you're going to come out for your decibels. So you look here, 97 point something would be very loud. Make sure you physically plug this into your calculator. Be sure you understand how to do that. And so very loud must be the answer to that one. Alrighty. That's how you go about that problem. Literally, you're substituting in using a little bit of scientific notation and then picking up a calculator. Alrighty. Okay, this one, number 18. It said in 2013, approximately 1.6 million students took the critical reading portion of the SAT exam. The mean score, the modal score, and the standard deviation were calculated to be 496, 430, and 115 respectively. Which interval reflects 95% of the critical reading scores? Okay, so when they say these are the scores respectively, they're telling you your mean is 496. Your mode, the score that was the most, is 430. And your standard deviation, they're telling you, is 115. When you look at a normal curve, and this is something you should have learned in class, but 68% of the scores are within 1 standard deviation above or 1 standard deviation below the mean. This right here, this center value is your mean. 95% of the scores need to fall either 2 standard deviations above or 2 standard deviations below the mean. So whenever you're talking about a confidence interval of 95%, the score up here that doesn't matter at all is the 430. When they talk about standard deviations and confidence intervals, they're relating mean and standard deviation. And 95% of scores fall within 2 standard deviations above or below the mean. So if you take your mean and you add on 2 times your standard deviation, or if you take your mean and subtract off 2 times your standard deviation, that will tell you where 95% of your scores fall. So your standard deviation is 115. And if it's 95%, you need 2 standard deviations above, 2 standard deviations below. So you got to take your 115 times 2. 5 times 2 is 10, put down a 0, carry 1. 2 times 1 is 2, and 1 is 3. 2 times 1 is 2. 230 must be 2 standard deviations. So first of all, the ones that don't even have a shot or anything involving the mode, 430 doesn't even have a shot. Okay, because when you're talking confidence intervals, you're talking the mean and you're talking some standard deviations. If they ask for 68%, 68% fall within 1 standard deviation of the mean. But if they want 95%, you take your mean, 496, and you add on or subtract off 2 standard deviations. So that's your 230. So hopefully this normal distribution looks familiar to you from class. Let's move on. Alrighty, and 23 you had an issue with. It says, according to a pricing website, Android phones lose 58% of their cash value over 1.5 years. Which expression can be used to estimate the value of a $300 phone in 1.5 years? So hopefully you know this formula. What the value after at the end of your 1.5 years will be whatever your original value is, your principal, and then you have e to the rate times time. All right, so here's the deal. If it loses 58% of the cash value, that means it's retaining 42% value. I'm going to go ahead and do what I think you would do. And then I'll show you kind of what I would have done. But I think you probably would say, okay, my principal is 300. My initial value is 300. And my ending value is 42% of that. So I think you would do 300 times, this is what I think you would do, times 42. Because if it loses 58%, it's retaining 42%. So that's 0, 0. Hopefully you're using a calculator. 2 times 3 is 6. I don't have a calculator in front of me, obviously. 0, 0, 0, and that's a 12. Add that together. 0, 0, 6. I don't think that's right. I think I figured it out before to be 144, not 126. 4 times 3 is 12. 0, 0, 2 times 3 is 6. All right, I don't know, I'm getting 126 right now. Move that over, we're going to say 126. 126, because if it loses 58, 68, 78, 88, 98, yeah, 42. Okay, so then this would be 126 is the value now equals 300 ERT. All right. So then I would divide both sides by 300, divide both sides by 300. What you're really going to end up getting here, 126 divided by 300, is that 42% that's still remaining equals e to the RT. Natural log on both sides, that's the inverse of e. So we're going to take the natural log on both sides. Bye-bye, get rid of that. So we have the natural log of 0.42 equals RT. on your calculator, if you do your natural log of 0.42, you'll get negative 0.87. So then your actual equation would be A equals, it's going to cut me off at 15 minutes. 300, it's going to cut me off.